And here we go. The product rule of derivatives is the first times the derivative of the second plus the second times the derivative of the first. Now I'm going to put that in parentheses because I want you to realize that you take this and you add it to that. And it's just that simple. So if I give you, let's just take the natural log of x. Let's say 4 times the natural log of x. Now there's two ways you can do this problem. One is to pull out the constant, and let's say f of x is equal to 4 natural log of x. F of x is equal to 4, and then put in parentheses or brackets natural log of what? X. Well, remember when I told you that you could pull out the constant and you don't have to deal with it as far as the derivative? Remember me telling you that? Okay, back when we were pulling out the 200 and I said you could distribute it and get the same thing? Well, that's what I'm doing here. And now what has the variable in it? This. So now I'm going to take the derivative of that, and we get f prime of x is equal to 4 times, I'm going to take my derivative now, and the derivative of the natural log of x is 1 over x, and of course this is 4 over 1, so 4 over what? Okay, is equal to 4 over x. That's your final answer. That's one way of doing this problem, using just the net derivative law. Does everybody understand that? Okay, you got one of those probably going to be on your homework. I think I put that on your homework or something like that. Now, this is not the product rule. This is just the basic. Take your highlighter, your handy-dandy highlighter, and highlight this, and put out to the side with this right here. Just put out to the side derivative of a logarithm. Derivative of a logarithm rule. Okay, so that's one way to do it. Capisce? Now, the second way you can do it. Oh, this is a whole lot better than math. What y'all think? It's amazing. It only took 3 weeks. Thank you. Well, this is state government. That's why. If it was federal government, it would be 2 weeks into the next 5 weeks before. Okay. Now, take your handy-dandy blue dot maker and put a dot right there, because that's what? What are you doing with that 4 and that natural log? You're multiplying. You've got a term here, and you've got a term here. So now we're going to use this rule. Now I'm going to write it out, and I'm going to do the derivative. I'm going to do the derivative in red. Okay. So, first times the derivative of the second plus the second times the derivative of the first. I'll take my red marker and I'm going to put first times the derivative of the second, natural log of x prime times 4 prime. Now, what's the natural log of, what's the derivative of the natural log of x? 4. No. No yawning in class. Okay? We actually had a teacher in CPT 170 that if you yawned 3 times, she would ask you to leave.
CPT? That's
Yeah.
a computer program.
CPT 170, yeah.
It's the easiest class ever.
I know. But if you yawned 3 times, she would ask you to leave. I don't see how she could do that. I'm just kidding about it, but she's actually had people leave. I'll do this one for you. What do you end up with? 4 over x, same thing. 4 over x plus what? 0 times anything is what? 0. You like those zeros because they cancel out everything. And that's how you do the... Now, of course, they're not going to be that easy. We'll do another one. And I think we're going over 5... What chapter are we in? 3.5. Yeah, 3.5 is a is where you start to see the product rule. Say again? Yeah. I'm going to put another one up here and let y'all do it. Let's do 2x times x squared plus 4. Yeah, just come on in whenever. That's fine. How was IHOP? Was it good? Oh, okay. Well, how was breakfast? Rushed? You're going to be late. You might as well just go and get you a pancake or something. I give everybody a hard time. You're tough. You can take it. First times the derivative of the second plus the second times the derivative of the first. Now remember, what's in that parenthesis, that's one term. While y'all are doing that, I'm going to go find some more problems we can work on. No sneezing. Please stop. You do it one more time, you have to leave. Then you can go get some pancakes. Let's go with Stewart. No, let's see if derivatives. Product rule. No. I have had a headache all morning. Huh?
You have an awful grade on there.
I know, I suck. Yep. Oh, I thought I froze it. I didn't freeze it. Okay, it don't work.
It's frozen now.
Okay. I thought okay. All right, so could you do this another way? Yes, there's two ways you can do it. Name one way. Well, I bet one way is the product rule. Yeah, that's true. What's the other way? Just what? Multiply by using what? Distributive law, Hubert. That's right, class. Use the distributive law, and you can actually do it by the one term. You can do it. So there's a way you can check it. All right? So let's do it both ways. Let's do it first by distributive law. And that'll give us, this is the distributive law and basic derivative rule. So 2x, that'd be to the first, that's 2x to the third, plus 8x. Now use your basic derivative law. That gives you what? 6x what? Squared plus 8. And you feel good about yourself. Now we're going to do first times the derivative of the second plus the second times the derivative of the first. 2x. So, what's the derivative of x squared plus 4? So 2x times 2x plus x squared plus 4 times what? Times 2. So now we got to do nothing but algebra. Again, another question is 90% algebra, 10% calculus. 4x squared plus 2x squared plus what?
2x is 6.
Hmm?
It says 2x is 6.
I have no idea where that 6 came from. I said 2x squared, didn't I? It's the drugs. Okay, 4x squared plus 2x squared is 6x squared plus 8. Does that look familiar? Yes. It's the same thing we got here. Now, my suggestion to you is when you do these problems, don't do them one way. Do them what? Two ways if possible, because you're strengthening your derivatives. Okay? Let's go to our handy-dandy clear board. And let's pull up one of your problems for your homework that you have that I just signed 20,000 problems. All right, try that one right there. 5x plus 8 times x cubed minus 1. And do it both ways.
This is 3.3 homework.
3.5. Yeah, I got to put 3.4 on there, but I have no idea what 3.4 is. This come out of Larson, so it's 3.3 in Larson. That's a different book, because this book, what? Sucks. I told my department head this morning, I said, I don't want to teach this course again if I got to use this book. I said, if I have to teach this course again, I'm going to tell the students to get another book, which I'm not allowed to do, but I'm going to. Oh, I don't know. I don't know if she's got somebody all ready for 2:30, then chances are it's not going to be changed, because summer we have to have so many classes. And if that class is made and somebody's got it, then full-time faculty would be, hey man,
Hey,
how's Calc 3?
I got a question. That's why I'm here. I've been looking for you. I drove to Anderson and they were like, you're here. I'm like, what the hell? You're never
Well,
here.
you should have texted me.
I didn't think
What
about
kind of question is it?
It's on one of my problems on website. What's your class about?
Can you copy it and send it to me?
it today,
What for?
because I got a test tomorrow.
What's it on?
Uh,
I get out at, what time I get out?
11:40.
I get out at 11:40.
Alright. Are you gonna be here?
I'll
for
be
the
in this
test?
room till about 12.
Alright, well, I'll come see you then.
All
Thank you.
right, see you. Come to me with a differential equations problem right before the test. You suck. All right. I had him. Yeah, I'll tell you the story about that guy. He came about 3 or 4 semesters ago. He took my college algebra course. Didn't have a clue what was going on. Didn't have a clue how to distribute a negative. Didn't know how to. I said, man, you don't need to be in here. We need to get you in a class to. So we got him in 102, 101, and 102, and that was like 3 or 4 semesters ago. And now he's in DiffEQ. So it's doable. You just got to be taught right, and you got to be placed right. He was set up to fail by advisor. Put him in college algebra, and the reason he put him in is because there wasn't any other math classes open. College algebra is a bear. That's Math 110 for those that don't know what it's called. I tell my advisees, take Math 110 before you take 130. Oh, my so-and-so told me to take 109. No, take 110.
I got to put it 109.
Huh?
I got to put it 109.
You know what 109 is? A watered-down version of 110.
The weird part is I have Gaddafi.
Gaddafi.
Yeah,
Gobadi.
go body.
Gaddafi was the leader of Libya. Gaddafi. Masalama. That's what they taught when I was in Saudi Arabia and Iraq. They said, don't shake with your right hand and say Masalama. That means go in peace. All right, y'all ready? 2 ways to do it. Let's go to the handy dandy whiteboard. 5x plus 8, x cubed minus 1. 5x plus 8, x cubed minus what? Oh my gosh! Shortcut number 5, Hubert. That's right, class. So 5x plus 8 times x minus 1 times x squared plus x plus 1. And then that's going to be 5x plus 8. And then if you distribute, so you do the FOIL method here, sorry.
What happened with x cubed minus 1 to x minus 1?
Shortcut number 5 that I told y'all to learn back in chapter 1. And I told y'all if y'all didn't learn them, what would happen? You would fail life, live in a ditch. Okay, so make sure you know that one. So do the FOIL method, 5x squared plus negative 5x plus 8x, huh?
You don't have an X.
Thank you. I'm gonna make a good wife one day. Get all these little nitpicky things. I'm kidding. 5x squared, that's why I'm not married. 5x squared minus 5x plus 8x minus 8. And then that's 5x squared minus b plus 3x minus 8 times x squared plus x plus 1. Now what? Good old distributive law. Are we dealing with the shovel or the backhoe? We're dealing with the shovel. So make you appreciate the backhoe. That's my problem. I write too big. All right. So 5x cubed plus 5x, I'm sorry, to the 4th. 5x cubed plus 5x squared plus 3x cubed plus 3x squared plus 3x, y'all help me out, I'm doing this in my head, 8x squared minus 8x minus 8. 5x to the fourth plus 8x cubed plus 8x to the fourth, wait a minute, 8x squared, wait a minute.
8x cubed.
Yeah, I gotta mess up somewhere.
Oh, it's 15.
The 8x to the second.
It cancels, doesn't it?
Yeah, because it's 8x.
Okay, that's what I thought. Okay, 5x squared plus 3x squared is 8x, and 8x minus 8x squared, there we go. Plus 3x minus 5x, right? Minus 8, is that what y'all got? Check me.
Yeah.
And now we can use our derivative rule, which will give us 20x to the third plus 24x squared minus 5. Now, we're not worried if that's the right answer because we're fixing to check it with the product rule. Okay? So I'm going to take my handy dandy shrinker, shrink this down a little bit. And 5x plus 8 times x cubed plus 1 first times, thank you, times the derivative of the second x cubed minus 1 prime plus the second times the derivative of the first. Okay, so 5x plus 8 times 3x squared plus x cubed minus 1 times what? 5. That's wrong. You're supposed to be able to use the, okay, forget that. That don't work no more.
That'll take an extra 3 weeks.
Yeah, that'll take another 3 weeks. So we better just take what we got, right? Oh, we're still waiting for training on these things too. We got them at the beginning of the fall semester. No, spring. What was last semester? Spring? Fall. We got them fall, and we're waiting on training. 15x to the what? Third plus 24x squared plus 5x cubed minus 5. And now those 5x cubes will give us 20x cubed plus 24x squared minus 5. And check to see if they look the same. Now, did I have to do all of these steps? You could have knocked out maybe one step, and that's that first one. You probably could have done the derivatives in your head. So 1, 2, 3, 3 steps versus 1, 2, 3, 4, 5 or 6 steps. Again, the 2 things I'm supposed to teach you, in my opinion, in this course, is how to interpret a graph and how to do derivatives backwards and forwards. That's what I'm supposed to do. So let's do a nerding. Because I guarantee you somebody has taken this course and they had no idea how to do the product rule. And the reason is if you look at the explanation of the product and quotient rule and the chain rule, you have no idea what it says. Capisce? Okay, nobody's going to talk to me. Y'all mad at me.
We're just thankful.
You're thankful. I'm Hubert. There we go. Do that one. Remind me, who took this class before? When you did the product rule and the quotient rule and the chain rule, was it like that or were you confused? Okay.
Did you finish the whole course?
No,
I finished the whole course.
Yeah.
And finally it clicked.
Because Pepper decided that she was going to fail the like halfway through, so I was just like, and
Gotta hate it when teachers do that. They don't like you. But I don't like all of y'all, so it's probably gonna have to be y'all too. What?
I said, joke's on you, I'm dropping.
Well, sometimes things are meant to be. I didn't need that $2,500 this morning. I wrote a check for. I didn't need it. Things are meant to be. You didn't read your email? Okay, then you don't know.
Don't worry about it.
It's just meant to be. I could have bought a new bed for my truck.
Could have bought a whole new set of treads.
No, I just bought a new set of tires.
How much do dually treads cost? You have a dually, don't you?
Yeah.
Shit.
They were 240 a piece, but I bought the Michelin's, the ones that last like forever,
Oh, yeah.
because I go up and down the highway a lot.
Yeah, no point.
When I'm hauling cattle. This headache is one of those headaches. It's just aggravating. It won't.
What'd you drink?
Huh?
What'd you drink? Need coffee?
No, Hubert don't drink coffee. Drill instructor, remember? That drill instructor really helped my health. He really did. But I never had a taste for the Marlboro Club. At Marine Corps Ball every year, they'd pass out cigars, and I'd give mine away. I just could never get a taste for that or coffee. And beef liver. And meatloaf. Just give me a hamburger. Don't try to give me a hamburger and disguise it as some kind of meatloaf. It's nasty.
What is the drug?
1X. I need me a ring like that. That's what I need.
So tell me why I went to the courthouse this morning, right?
Don't even get me started
No.
on the courthouse.
No, listen to me.
I got to go to the
So-
courthouse because my alimony ends when I graduate, and it says that in the divorce papers. But I got to have a court tell me that. I'm not gonna pay it.
Well, I got a traffic ticket for like a rolling stop sign, which I did not do because I just bought my car. I'm not gonna roll a stop, you know. And then she pulls me over, gives it, and so then I'm like, okay, I'm gonna fight it in court because usually if I'm speeding or something, I'll just pay it. And she didn't even tell me how much it was gonna be, so I had to ask her, and she was like, oh,
City or
135
university?
to 230, and I was like, that's like a bill. So I went to the courthouse. Remember, I went yesterday, but it wasn't till today. So then I went today, and then the first thing the judge says is, well, if you're here for traffic violations, I can't lower your fine or do anything for your points. So you can leave if you want. So I was like, I just wasted my time. So I left, and I just paid it when I could have done it online like a month ago.
It's a conspiracy,
I hate it.
and we all know whose fault it is. Bush's fault.
In Clemson?
Do you know what classifies a stop? I had to look it up. You have to go back. Yeah, your car has to go back. It has to do this. Who's going to sit there and watch that? Only city and university usually do that. Was it city or university?
It was city.
To get a little revenue.
I just didn't know you couldn't find it if you got, basically if you get.
University, they throw you in jail and tow your car if you don't.
Really?
I'm serious. Listen, I was carrying a guy with half a leg to the library one day, and I had to go in there. So we had the little handicap thing, and we walked in, and I come out, and I had a dadgum $300 ticket. And I'm like, but they thought that I stole it and put it on, because she sat there and watched me get out of the car. Well, see, I dropped him off at the front, at the side of the library right there, the little parking lot. I dropped him off right there, and then I went around behind that, I can't think of the name, it's right beside the library, but anyway, right there, there's a parking lot back there, and I parked back there. There was a handicap parking, and she watched me get out. And she was back there. She watched me get out, and I was walking regularly, and she gave me a $300 ticket. It took me a whole semester to get that ticket taken care of, with him going to the university with me, university police with me, testifying that I was bringing him to the library.
She's a meter maid, she's a detective.
Thing at all is like $1,000.
Huh?
The tickets now is like $1,000.
For handicap?
Yes.
It's a maximum of
They
1,000.
have pictures on the thing now. Like,
Yeah.
It's supposed to have your picture on the
Uh-huh.
handicap thing.
Well, I think that's smart, but I was just carrying him to the library. Good gosh.
Get out and just have you stupid.
Huh?
How many
I always tell my mom,
stops
just
sign?
get out and like fall on the ground.
What?
I'm asking how many.
Oh, 4.
Yeah,
Yeah.
it's a reckless driving charge.
That's
What is? Rolling a stop sign.
And I didn't even roll it. Like, I stopped, but I couldn't really see all the way, so I moved up a little bit, made sure, and then I went and she pulled me over.
All right, now unless you like punishment, you don't have to do it by the FLIL method, and then that's only if you want to practice. All right, so what's the first times the derivative of the second? Well, the second is going to be what? 1 minus plus the second. You're still going to have to use the FLIL method. Times the derivative of the first, which is going to be 12x. And this is going to be 1. That's going to be minus 2x plus 6x squared minus 12x to the third plus 12x squared minus 12x to the third. Y'all check me.
Yeah, you're
And
right.
it looks like we're going to get something to cancel out. Maybe that.
No, you just have to combine
That
terms.
sucks. All right, so 1 minus 2x plus 6x squared minus 12x cubed plus 12x squared minus 12x cubed. Because I distributed this one, that one right there, and this one right here. Get rid of the parentheses. So that's going to give us negative 12x cubed. That knocks that out. Oh, I'm sorry, negative 24x cubed. 24x cubed plus 12x squared plus 18x squared minus 2x plus 1. Y'all check me.
That's right.
That's that one. Okay, now let's throw in the rewriting, manipulating then. So let's do this one right here. And hopefully if that encourages you, this will discourage you. So let's move on down. And we can do both of those. Yep. Seven times e to the x square root of x. Y is equal, okay, don't do that one because, yeah, you can, because you can bring the 5x squared up. And then we'll do the quotient rule after we do that one.
Is the radical its own term?
The radical is the square root of x. What'd you say?
Is it its own term? Is it?
Yeah. In other words, 7e to the x is the first term, and square root of x is the second term. And what should you say to yourself when you look at that problem? Radicals and calculus don't mix. I would quit. Because then you have to, just quit. I tell you what, do what I used to do, erase the radical. That really works well.
My sister used to.
Dr. Gabati, I do not understand where this problem came from. I was bad. You just don't know. Not everybody was born with a 1800 SAT. Teachers need to realize that. That's why I try to get y'all to quit. But y'all won't do it. Y'all keep trying. My headache will not go away. I've already taken, what do you call it, Excedrin? Dang lawyer's fault. All right, this one's fairly simple because you don't have a lot of binomials and all that good stuff. So first I'm going to rewrite it. 7e to the x times x to the 1/2 power. Now, the 7 I can pull out to the side, but it really doesn't matter. You could actually do the product rule here too if you wanted to. But you see what's going to happen with that 7 over here when you do the derivative of the first. What's going to happen? You're going to get 0, and that term's going to come out, and you're going to get 7e to the x. So however you do it, it doesn't matter to me. First times the derivative of the second plus the second times the derivative of the first. And this is going to be 7e to the x, 1/2 x to the negative 1/2, plus x to the 1/2 times what? The derivative of this guy is going to be what? 7e to the x.
Why?
Because the derivative of e to the x is what? E to the x. And if you do the product rule here, first times the derivative of the second plus the second times the derivative of the first, what happens here? See, the good thing about derivatives is there's ways that you can go back and check stuff. That's the good thing about it. You can use another method. You can put in an x to the 0 if you get confused. With 1x, you could put 1x to the first power and then do it. So it's kind of hard not to get basic derivatives wrong. Okay? Especially with the product rule, because the product rule, you can use multiplication. This one you can't because it's two different bases, but in the previous problems, you get the point. Here, you can do this right here and check it with the power or with the product rule and check to make sure you get the same answer. Okay? So this right here, what happens here, in every class you have students like this. You know the blue lines on your notebook paper? There are some students that try to do 5 or 6 steps inside those 2 blue lines as notebook paper. This is not the time to do it, all right? When you're doing this type of problem, especially with an exponential and a logarithm, which is e, okay, then you're going to have several steps. So what I would do first is take care of this. So 7e to the x over 1, because that's a constant. I'm going to put it over 1 because this is going to be what? Fraction. And this is x to the negative 1/2 over 2, so what am I going to do? I'm going to bring this downstairs, and that's going to make it what? 1 over 2x to the 1/2. That's that. Notice I'm putting another step in because I don't want to screw it up. And then x to the 1/2, this is all one term, so I'm going to go 7e to the x times x to the 1/2. And now I get 7e to the x over 2 square root of x plus 7e to the x times the square root of x. That's probably going to be your answer. I'll type in some stupid answer and let's see what it tells us. I don't think they're going to ask. The only thing I could see that they would ask you for is to rationalize this denominator, but I don't see that. I wouldn't want you to do that. So I'm going to type in 3. What do you do? Hit submit answer. Takes several hours for it to come back. What do I do? Where's the answer? Oh, there it is. 7/2. See, they didn't even, they did this. 7x to the 1/2 e to the x. Where the heck did they get to it? They factored it out right here. What's in common? 7e to the x. They factored that. They factored out of 7/2. I don't care. It's still the same answer. You get 7. If you take out 7x to the 1/2, 7/2 x to the 1/2, you get this. I don't care about that. This is good enough, and this is good enough right here. But I don't want to see that negative exponent. Okay. Does everybody see where they did? They factored out this guy, and that left 2x plus 1. Factored out here, you get 2x. Factored out here, you get 1.
Now which one is this? 3.3?
This is 3.5. I'll take either one of these answers, or I'll take that answer. So if you get this answer, make sure you save your work and show me, and I'll fix your homework, okay? Unless you want to factor that out. Everybody see this? Let me just do this right quick for you. Take your highlighter out and highlight the 7e to the x and the 7e to the x. Okay, so that comes out. And then they also factored out a 1/2 x to the negative 1/2. Why x to the negative 1/2? Because you always factor out your lowest exponent. And that's why this changes this to a 1. Okay? At least that's what it looks like.
Both terms don't have 1/2 common.
You've got 7 over 1.
7 right here. Take this. 7e to the x times 1/2 is 7e to the x over 2. And when you divide by 7/2, you multiply by 2 over 7, and that's how they get a 2 here. I don't really care about that. All right, let's move on to the quotient rule. And then you can check your answers by the quotient rule, because you can, I'll show you what I mean in just a second. The quotient rule says
What section is this?
I don't know where the quotient rule is. Probably, it might be in 3.5, but I don't know. I'm just teaching you this because this is the last rule that you need in order to be able to maneuver through all derivatives. The basic rule, the power rule, the chain rule, the product rule, and the quotient rule, and of course the logarithm and the exponential rules. You know, the derivative of natural log is 1 over x, that kind of thing. All right, so denominator times numerator prime minus numerator times denominator prime over denominator squared. That's how you do it. Now make sure you write that out so you won't call me up tomorrow or ask me, what does D stand for? Okay, denominator.
So basically,
Quotient means it's fraction, numerator and denominator. Now let me tell you, you want to see something confusing? Look in your book under quotient rule and see how they write it. They got f of x times f of x prime or g of x, g prime of x minus g prime of x times f, or g of x times f prime of x over g of x squared.
Hey, remember.
technically wouldn't this be the product rule divided by the second term?
No.
First term?
Product rule is plus. And you're dealing with the first and the second. But you can change it around. Let me show you an easy example. 2x over e to the x. Now, I want you to do it two ways. Okay, while you're figuring out how to do it two ways, we're going to get down the hall for a second. All right. So, what's the other way you can do it besides the quotient rule? Come on, think. What the heck is this? No, what do they do?
Oh, the whole paper bubble.
Why are they shaped like that? That's gonna bother me. Okay. Give me another way to do it.
You bring the denominator up.
Bring the denominator up. Good, and use the product rule. And that's how you can check these problems. So one way to do it is f prime of x is equal to 2x times e to the what? Negative x. Now you can do it that way, which then you have to deal with a negative. But the derivative of e to the negative x is what? Negative e to the negative x. Because that negative comes out. Negative 1 comes out. I wouldn't do it that way because this is going to mess you up. But if this was another term, then you could do it like that. Denominator. What's the denominator? E to the x.
Yeah.
Times the numerator prime. Minus the numerator. Times the denominator prime. I'll do that one for you. E to the x. Over e to the x what? Squared. 2 e to the x minus 2x e to the x over e to the 2x. Can we factor out anything? Yes, you can factor out a 2 e to the x. I'll take this answer if you were doing a test, if you want to stop there. Or you could factor out 2 e to the x, and that will give you what? 1 minus what? X over e to the 2x. So I'll take either one of those answers. And of course, if you did this, that would be 2x e to the negative x prime plus e to the negative x times 2, and that's going to give you, you see the negative x right there, and the negative x here, so you're going to factor that out, and that's going to come down, and there's the 2 and the x, so you can see that it's going to work there, but that negative comes out. That's going to be 2x negative e to the negative x plus 2e to the x, and that's going to work out to come out to be like that too. So let's do one like that. All right, try that one. And usually that's why they don't put e to the x on the bottom. But anyway, try that one. You can do that one both ways. 2 comes out front. 2 times 5.
So it's the next.
10x, yeah. All right, you can do this one both ways because you won't have that nasty e to the negative x. So if you wanted to check it, let's go e to the x times 5x squared first times the derivative of the second plus the second times the derivative of the first. So that's going to give us 10x e to the x plus 5x squared e to the x. And you can factor out a 5x e to the x. Y'all check me. 5x e to
Isn't the
the
5x to the square supposed to be -2? Because you brought it up.
You're exactly right, thank you. -10, -10, got that. Is that better? And that would be, you could factor out a -5. I'm going to factor out a 5, and then I'm going to keep the -2 in. So 5x e to the x give us a what? -2?
It would be -10x to the -3. Like it's the second row. Like it's gonna.
Okay, hold on. Just hold on. I'm going to start over. Because evidently I just screwed the whole thing up. Let's try it again. E to the x times 5x to the -2. How about that? First times the derivative of the second would be -10x to the -3. How about that? Plus the second times the derivative of the first. How about that? That looks a whole lot better. -10x to the -3 e to the x plus 5x to the -2 e to the x. Well, first thing I'm going to do is get rid of those x to the -3 and x to the -2. So I'm going to bring that down. I'm going to bring this down. I'm going to bring this down. And that's going to give me -10 e to the x over x to the third plus 5 e to the x over x squared. You could factor out 5 e to the x over x squared. I don't know if they did this or not. 5 e to the x over x squared, and that would leave us with -2, don't check me, over x plus 1, right? So there's 2 possible answers. Now let's check it with the quotient rule and see what we come up with. Y'all write those 2 answers down. And let's check it with the quotient rule and see what we get. Denominator times numerator prime e to the x minus the numerator times the denominator prime over denominator squared and that's going to give us 5x e to the x, 5x squared minus, go away, 10x e to the x, oops, really, e to the x over 25x to the fourth. And it looks like I can cancel out some things. you could cancel out some x's. So let's cancel out x will go into all of those. So that goes out, that goes to x, and that goes to x to the third. And then we could factor out a 5. That'd be 1, that'd be 2, and that'd be 5.
Yeah, e to the x.
So looks like we can do, I'm going to go ahead and, the e to the x can't cancel. We can factor it out. But let's write what we got because we got a mess. We got x e to the x, right? X e to the x over 5x cubed minus 2 e to the x over x cubed, right? Or 5x cubed, sorry. And what happens to these two x's? They cancel and you get e to the x over 5x squared minus 2e to the x over 5x cubed. What did we get before? E to the 5x. Okay, we got 5x squared. I thought, what happened to the 5's? I guess we cancel them out. We got something wrong with the product rule. Or I got a different thing with the product rule.
I think the 5 got inverted back to the top.
Wait a minute. Here's the 5 right here, and the 10 is right here. Trying to see what happened. Because I got them on the bottom up there. I did something wrong.
Did you not bring the 5 down?
Can't bring the 5 down. Well, let's see what the answer is. I got 2 different answers. I'm pretty sure it's probably the second one. I made a mistake probably on the first one. Submit.
Okay, that's what I got.
They didn't factor out.
Yeah.
They left it 5x cubed. They factored out at the top right here. They left it 5x cubed.
And just put them together.
Yeah, right here. There's the answer right there. Right here's the answer. Now my problem is what I do wrong here. First times the derivative of the second plus the second times the derivative of the first. Negative 10, x to the third, e to the x, negative, plus 5, x to the negative 2, e to the x, bring that down, unless they got a common denominator. That's what they did. They got a common denominator right here. Well, that still would just give us another x here. That'd be 5x e to the x over x cubed.
Then you would factor out 5.
Yeah, but how did they get the 5s down here?
I did it like that, but instead at the end, they ended up canceling.
What did you say? I'm sorry.
So to mine, like I factor out 5x e to the x, and in parentheses x minus 2 over 25x from before, and then they took that 5. And
Okay, I'm gonna figure this one out. I'm gonna figure this one out because you should be able to do it both ways, and I've done something, or I haven't gone far enough. I'm thinking a common denominator, or see, I have e to the x, right? There's my e to the x.
Did they bring down the 10? No.
Because of the negative 10
Yeah.
and 5 is x minus 2.
They're all together.
That negative 3 is with that x. That negative 2 is with that, unless,
They brought
Are
it down
you
way
able
too
to pull
high.
that down without bringing the 5?
no, you cannot. I'll figure it out, y'all. Don't worry about it. Just you do the quotient rule, and I'll figure it out. I got 2 questions to go over tomorrow. So, and one I got to figure out if it's even right or not. I got to take the roll, so y'all just hold on. Y'all got 5 minutes. I got 5 minutes. Y'all know that, don't you? So that means everybody sit down. Y'all know how to hit my nerve. That's my nerve, okay? I don't like that. I can handle a lot of things. That's just one of my pet peeves. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 2 people. Gotta call the whole roll for 2 people. Huh? What do you mean one left? Somebody leave?
Yeah.
My back's turned to y'all all the time. Who left?
No, I'm saying one withdrawal.
Oh, yeah. Today's Wednesday. All right, who's not here? I'm just kidding. Beck, Bendenball, Bowers, Branyan, Bundrick, Cromer. Huh? Cromer's here. Cromer, Dove, Griggs, Hildebrand's here. Knott, Keebler, Lilly, Montero, Seidner, Sullivan. Sullivan's not here. Yeah, he's not here. He sits front. Thomas, Walker, and White. Okay, y'all have a good day. I've already loaded 3.5, so look for 3.4. I'll put it up there sometime. Miss Branyan, I'll check on your question, and I'll check on this too.
Hey,
Yes.
so you know you're this assignment from the DS.